And we're live, yeah. Chapter 4.4, Properties of Logs. Now, of course, when we say logs, that means what? Logistics? Logarithms? Or like wooden poles? Wooden poles. So, properties of logs, I guess the top of the list would be wooden. Oh, barky. I like that. Barky. Which reminds me of my favorite joke. What is brown and sticky? A stick, right? That is like my favorite joke. It's my favorite joke. What is brown and sticky? A stick. There is probably no better adjective for a stick than sticky, right? If you had to describe a stick, you'd say, well, it's sticky. But barky, I like barky too. I like barky. Of course, we're talking about logarithms. So let's look at the properties of logarithms. Now remember, what is a log? Not to lose sight of what a log is. It's a what? It's an exponent, right? We know that. So really, the properties of logs that we are about to learn are really just the properties of exponents. Very similar to what we just reviewed in the warm-up. Marcia, you singing out loud? Yeah? I don't know. Can you take your earpiece out? There you go. I mean, you can still have the song in your heart. Okay? All right. So let's review the properties of exponents that we just did in the warm-up. X to the 8th times x to the b. What do we do with the a and b? We add them, right? Because we're multiplying. It comes down one rung on the operational ladder. It turns into addition. So multiplication becomes addition. Okay? So here is the property that works for all logs of any base, but I'm going to illustrate it with base e, natural log. So same thing here. Products are going to become sums, just like this, right? Multiplication became addition. Products become sums. The natural log then of a product, a times b, turns into a sum, addition. It's the sum of the logs, okay? So natural log of a times b is equal to the natural log of a plus the natural log of b. So each factor gets its own log, and we do what with the two factors? We add them, okay? It is not equal to the natural log of a times the natural log of b. No. Addition is what we get, okay? So multiplication becomes addition. Let's try it out. Example 1, it says to expand. What does expand mean? Let me go ahead and show you what it means. If we go from left to right, this is called expanding. And if you had logs in Algebra 2, some of you might have, whether it was last year or 2 years ago, you learned these properties. Expanding is when you're going from left to right. You're creating more terms, okay? But the rules also work in reverse. So if you're working the other way, what would be an antonym for expanding? Despanding. Despanding. Good one. I wasn't there at the meeting, but I would have voted on that one. Not condescending, but condensing. Yeah. So if you go from right to left, a sum of two logs becomes the product of their arguments behind one log. So that's called condensing. All right, so let's go ahead and expand. The natural log of 3 times 5, well, that's the natural log of 15, right? 3 times 5 is 15. But we can, instead of saying 3 times 5 is 15, we can expand this out, and we could say it's equal to the natural log of 3 and the natural log of 5. And what do we put in between them? A plus. Good. They're multiplied, so it turns into a plus sign. Cool. Neato, mosquito. That's easy, right? Tostitos. Letter B. I want you to do it now by yourself. Natural log of the quantity 4xy. Expand it. And again, these work for any base. Works for base 7, base 1/7. We're just trying to get in the habit of using base e, the natural base. All right, you should be done, right? How many factors do we have in our argument? Remember, what's an argument? It's the thing we're taking the log of. So how many factors do we have in our argument? 3. We have a 4, an x, and a y. So how many terms should we have in our expansion? 3. So does it become the natural log of 4 plus x plus y, like that? No, because those, then the only difference would be the argument, and multiplication is not the same as addition. They each get their own log. It's the natural log of 4 plus the natural log of x plus the natural log of y. Okay? So what logs do is they make molehills out of mountains. They take things that are products and turn them into addition. Again, making it smaller. More terms, but the arguments are now simplified. Okay, condensing. Let's go the other direction now. So now you look at it, and how many terms do we have? 3. We have 3 terms. Is this one fully expanded? Yes or no? No, it's not fully expanded because I could call that first term natural log of 4 plus the natural log of x, and I can call the second term the natural log of 3 plus the natural log of x. But I don't have to do that if what I'm trying to do is condense. So it doesn't have to be fully expanded. So here's what you're going to do first. You're going to realize that there's 3 terms and they all have a natural log. So you're going to pull one natural log out front. So instead of giving each term a natural log, you're condensing it, you're pulling one natural log out front. And go ahead and write your 3 arguments then. You got a 4x, you got a 3x, and a 2. And what do we do with those on the inside? Do we add them together or multiply them? We have to multiply them, okay? So at this point, it's a real good thing to just go in reverse and say, okay, if I had to expand that, what would it be? It would be the line above, okay? Because that's typically where students make the mistakes. They'll put plus signs there. It's like they're factoring out a natural log, which is not what we're doing, right? We are not factoring out a natural log. A natural log is not a symbol. It's not a variable. It's not a number. It's a function. So we're not factoring out a function. We're using a property to condense. So those are multiplication. And now all you got to do is simplify the inside. So what is 4 times 3 times 2? You can multiply all your numbers together. 24, yeah. And then x times x is x squared. There you go. Now you really don't even need parentheses around it on the end. You can just call it natural log of 24x squared. In general, if there's no parentheses after a log, you're going to assume that the first term is the argument. In other words, if I would have had like a plus 5 here, I would assume that that's the natural log of 24x squared, pause, plus 5. And if I wanted the argument to have the plus 5, I would need parentheses, okay? But I just made that up. So that's your answer, natural log of 24x squared. All right, let's see. Some of y'all might say, hey, let's expand it all the way. If we expand it all the way first and then condense it, should we get the same answer or something different? Should get the same answer. Let's see what that would look like. That would be the natural log of 4 plus the natural log of x plus the natural log of 3 plus the natural log of x plus the natural log of 2. Well, that wasn't really worth doing, right? Because if we're going to condense it now, we have 5 terms. So we pull one log out, and because they're all added, now it's just 4 times x times 3 times x times 2. So, again, it doesn't need to be completely expanded in order to condense. But if the instructions say to expand, you do want to expand completely. And if the instructions say condense, you want to make sure you condense completely. Okay, any questions on the first property? Products become sums, sums become products. All right. Property 2, hey, we did this one in the warm-up also as well. When we are dividing and the bases are the same, that turns into what operation? Subtraction, right? We subtract the exponent. So division becomes subtraction, much like multiplication becomes addition. Division becomes subtraction. So if we turn that on its head, the natural log, or the log in general, of a quotient, a divided by b, becomes the difference of the logs. The natural log of a minus the natural log of b. Now notice subtraction is not commutative, is it? So one of those has to be positive terms and the other has to be negative. Notice the negative term is the one that comes from the denominator. All right, so it's positive natural log of a, because that's in the numerator, and then minus the natural log of b, the denominator. So just like we would have done over here, we do a minus b, numerator minus denominator. All right, go ahead then. I think you could figure out this on your own. Natural log of 4/3. Go ahead and expand it. There's always some wisecracker on a test or a quiz when I say expand that expression. They put more spacing in between everything. And they're like, is that what you really wanted? Oh, okay. Yeah, because no one would deliberately take a hit on points, right? just to make a math joke, that's a pretty high price to pay. So when you don't know what you're doing, yeah, what else to do except maybe laugh at yourself and then try and share that laughter with me, I guess. Yeah, I don't know. No, so this one will be the natural log of the numerator minus the natural log of the denominator. And ta-da, you're done. If you had your calculator out in front of you, you can type them both in. Natural log of 4/3, enter. And natural log of 4 minus natural log of 3. Now, we don't have our calculators out in front of us because that's not the purpose of this activity. But if you were to type this into your calculator, because the previous worksheet did have some of those, remember when you hit ln or log on your calculator, it automatically opens a parenthesis, automatically by default. So you would need to make sure that before you then want to type in that second term, you need to close it. So minus and then natural log, it'll open a parenthesis and close it. So be very aware of the parentheses. But they're not needed there when you're writing it on your own. Okay, letter B. Go ahead and expand that one completely. You'll always have as many terms as you have factors. That's not completely expanded. You still have a 6x. Oh, okay, yeah, good. Some of y'all are doing it in one step. That's good. Plus, yeah, plus or minus. That's a good question. Is it plus or is it minus? Yeah, they're both in the denominator, but we're multiplying in the denominator. Yeah. So if you notice, you have three factors here: a 7, a 6, and an x. So you should have three terms. The question is, are they positive terms or negative? So if we do it in baby steps, that's the natural log of 7 minus the natural log of 6x. All right, we get that. But notice there's a minus in front. So if we were to then expand the second term, you would need parentheses or something. And so inside the parentheses now becomes the natural log of 6 plus the natural log of x. Because we're multiplying in the denominator, it's a plus sign. But we have it in parentheses. And now if you were to do what with that negative? Distribute, you get the natural log of 7 minus the natural log of 6, but then minus the natural log of x. So in the future, you do not need to show those other steps. You can go straight from the given expression to the full expansion. And a lot of y'all did that, I noticed. Okay? So I guess the rule is, and yeah, Wofford said it, right? Because the x is in the denominator, it's going to get a minus sign. So any factor in the numerator gets a positive term sign, and any factor in the denominator, you can just associate it with a negative sign. Okay? Let's try this one out. What would log base 5 of 7x over, let's just do 3 yz. I'll just throw more variables in there. Go ahead and expand that one out completely. It's log base 5, so it works pretty much the same way. Try to do it in one step. How many factors do we have in the argument? 5, right? A 7, an x, a 3, a y, and a z. So how many terms should we have? 5. That means we should have 5 logs written, because every term gets its own log. So with 2 factors in the top, there should be 2 positive terms, and with 3 factors in the denominator, there should be 3 negative terms. So it's log base 5 of 7 plus log base 5 of x, and then minus log base 5 of 3 minus log base 5 of y minus log base 5 of z. And that's it. That's expanding it in one fell swoop, we say. It's not as fun as natural log because you have to write that subscript each and every time, but it works the same way for any log. Okay? Questions on expanding? Yeah? You can with then plus signs in between them, but then I want you to go ahead and then take that extra step of distributing the negative, because it is considered more simplified when it has less stuff in it. And so if you can eliminate a set of parentheses, we say it's simplified. So what I'm trying to get you to realize is you don't have to show that step where you're leaving the minus sign out front and then having to distribute. You can just go straight to this line right here, okay? Because that's how I want it to end up in the end anyway. So every factor in the numerator gets a plus sign. Every factor in the denominator gets a minus sign, okay? All right, sweet. Go ahead and condense then. Again, that one's not fully expanded, but these rules work in reverse, so go ahead and condense that. Put it as a log of a single argument. Thank you. You got to practice. You got one log, that's good, but all the terms are negative, right? So all of those arguments should be multiplied where? In the bottom, right? I threw you a curveball right away, but that's okay. That's how you learn to hit. There's 3 terms, and they're all negative, and they're all natural logs. So when we condense, we pull out one natural log. Now the negative sign in front of each term just tells us that our arguments of 3x and 5x are all multiplied where? In the top or the bottom? In the bottom. So build the shelf, and then it's 3 times x times 5x. But if we leave it like that, that looks funny, right? What would we put in the numerator then? A 1. Excellent. Why would that work? Well, let's try it. If we were to expand it back out, this would be kind of checking. To expand it back out, it would be the natural log of 1, and then minus the natural log of 3, minus the natural log of x, and minus the natural log of 5x. And what is another name for the natural log of 1? 0. Yeah, remember, log base b of 1 for any base is 0. We learned that in the last section. They all pass through the point 1, 0. So the natural log of 1 is 0. So you could have imagined a 0 being there in front to begin with. And so that's how we get the 1 on the top. So now that we condense, we can go ahead and combine like factors since it wasn't fully expanded. That'll be the natural log then of 1 over, and you can multiply like factors together. So 3 times 5 is 15, and x times x is x squared. So that would be the simplified condensed version. And as I was walking around, I saw a lot of people with a negative in front of the log, a negative natural log. We haven't learned any rule that says you could bring a negative out in front of a log, right? All we're doing is saying, okay, products become sums, sums become products, quotients become differences, differences become quotients. If it's a positive term, the argument is multiplied in the numerator, and if it's a negative term, the argument gets multiplied in the denominator. All right, so let's try one more bonus one. Condense this one. Let's do log base a half of 5 minus log base a half of x plus log base 1/2 of 2 minus log base 1/2 of 3. Remember, terms can be written in kind of any order. Go ahead and condense that one. After you condense it, then you can combine like factors. Here's how your thought process should go when you walk up to it. You should first take note of how many terms you have. 1, 2, 3, there's 4 terms, right? They all have log base 1/2 in it. So to condense it, you're going to build, well, not yet. You pull one log base 1/2 out front. And you know you're going to have 4 factors now in the argument because you have 4 terms. 4 terms will turn into 4 arguments at least. If you have at least one negative term, we have 2, you know you're going to have a denominator, right? So build the shelf. If you ever have at least one negative log term, it's going to be in the denominator, so build the shelf. Let's go ahead and start putting arguments then on the shelves, right? What goes on the top shelf? Any argument that comes from what type of term? A positive. So that's going to be the 5 and the 2. Well, you don't have to show me the step of 5.2. You can just say, oh, 5 times 2 is what? 10. So that's going to go up there. And then the 2 negative terms, their arguments go in the denominator. That's an x and a 3. And you're done. Nothing divides out. The 10/3 doesn't divide out. So you're done. That's it. Log base 1/2 of 10 over 3x. Okay? All right. Questions on those 2 rules. There's only one more property. And I saved the best for last. It's my favorite. Property number 3. Okay? Property number 3. Let's review the exponential property first, because that's all these are. We did this in the warm-up, right? If you are raising a power to a power, that is called exponentiation. And we know that you come down one rung on that operational ladder, and it becomes what operation? Multiplication, right? So when you raise a power to a power, you multiply the exponents. So exponentiation becomes multiplication. Exponentiation becomes multiplication. Same thing with the logs. If you have the log of a to the power of b, b is now an exponent, it can turn into a multiple, okay? Notice, where does it end up? It ends up out front, and you're multiplying it. So exponentiation turns into multiplication. You could bring the exponent on the argument out front, and now it becomes multiplication. But it also works the other way around. So if you start on the right and you go back to the left, that is, if you start with something out in front of a log and you bring it back up as an exponent, that's called condensing, right? But if you bring the exponent out front, that's expanding. So again, the rule works both ways. But power on an argument becomes a multiple in the front. Okay? Let's try that one out. Part A, the natural log of 2 cubed. Well, 2 cubed is 8, so I know that this is equal to the natural log of 8. But can we write it differently than that? Yeah. I have a 3 as an exponent, so where can I bring that 3? To the front, and that becomes 3 times the natural log of 2. And that's it. And that's what logs do. They make molehills out of mountains. They take big numbers, and they chop them down to manageable size. Okay, 8 is not a huge number, but 2 is smaller. So when you're working with 2, it's easier than working with the bigger number 8. This Corby. Yes, good morning. I do. Yes, it will do. Tristan, Miss Beard needs to see you in her office. Yeah, you can take that. Maybe you'll be back. Let's hope you'll be back. We got 11 minutes. You might want to take your bag here. Yeah, go to the middle office. Yeah. Okay, so what's another name for the natural log of 8? 3 times the natural log of 2, or 3 ln 2. Very good, very good. All right, go ahead and do this one on your own. What'd you get? Sorry. I'll give you another second. What'd you get? 2 times the natural log of x. Piece of cake, right? You got a 2 on the x, bring it out front, boom, done. Exponents become multipliers out front. Woo! Yeah, I told you that was my favorite. Let's try condensing. That means going the other way, right? Now we have something out front. We're going to bring it back up as a what ponent? Exponent. Okay, good. Let's do this one together. How many terms do we have? 3. So we're going to have 3 factors in our argument. But before we condense, notice you have numbers out front. When we've been condensing before, the numbers out front have either been 1 or negative 1. So that's your first step when you're condensing. You want to make sure you have either plus or minus 1 as your log coefficients. All right, so that's what we're going to look for first. Well, I've got a 2, and a 4. The negative is fine. We'll leave it as the negative. So the first step is bring that 2 up here, bring that 2 up on that 3, and bring that 4 up on that y. And that's going to be the natural log of x squared plus the natural log of 3 squared, and we'll leave the minus there, minus the natural log of y to the 4th. So even though you can expand in one step, I would not recommend condensing in one step. Do it in baby steps. Okay, so that would be step 1. Now step 2, condense to 1 log. All right, so now it's 3 terms, so we'll pull 1 log out. So we got the natural log of. Do we have at least 1 negative term? Yep, so we know we're going to have a denominator, so we'll build the shelf. It's a lot easier to put things on shelves once the shelf's already built. So what goes in the numerator? The x squared and the 3 squared, right? Remember, if there's nothing in front, it's implied to be a positive 1. So 3 squared is 9, and x squared is x squared. So your numerator is 9x squared. What's your denominator? Y to the 4th. And you're done. That's it. Okay, so leave negatives in front. That's good. Just bring up the magnitudes. If they're not 1 or negative 1, bring up the magnitude of the coefficient on the exponent first. And then step 2, pull out the log and condense using properties 1 or 2. Okay? So those 3 properties, they're just the property of exponents. And they make logs very, very useful. Typically, when we use logs, we use them to expand because it gives us smaller numbers. Even though it's more terms, it makes the arguments much easier to work with because they're smaller. All right? One last one here, I guess we'll do it. Go ahead and simplify that one by condensing. I'll start you off with a hint. The log is in the exponent. So we're going to do this one in 2 steps. So it's just e to the, and pretend you're just working in the exponent. What would 2 ln of x become if we condense it? Ln of x squared. Yeah, that 2 comes back up as an exponent. And now we're done condensing, but does that simplify at all? What does it simplify to? X squared. Yeah, if you did your homework from the previous section, remember you reinforced the fact that b to the log base b of x is just x, and it works the other way around. Log base b of b to the x is x. Well, remember, x is anything. It could be x, 7, x squared, anything. It's blob. And it's because log base b and exponentiating base b are what's of each other? Inverses. Yeah, good. And remember, the natural log is log base e. So when you have e to the natural log of x squared, that's really e to the log base e of blob, which, of course, is just blob. But you can't do that until you get rid of that 2, okay? Because that 2 is there, you have to condense it first, and then you have e to the natural log. Okay, sweet. Now, let's do example 4 together. This is a proof, and you don't have a lot of experience with proofs. But we're going to prove property 2 and property 3 using the other 2 properties, okay? So property 2, remember, was this. We'll label it. We're doing property 2. That one's the one that said that if you have the natural log of x divided by y, that it was equal to what? Yeah, the natural log of x minus the natural log of y. We want to prove that. So here's how we do proofs. We had a little taste of this year. We draw a line down the equal sign, and then we have to work on each side separately, manipulating the expression to make one side match the other side. Okay, so we can work on both sides, but we have to keep it equal to that particular side. And since we're trying to prove property 2, we can't use property 2 to prove it, right? You can't define a word with the word itself. What's a dog? A dog? It's a dog. Thank you for clearing that up, right? I should probably know what a dog is, but if I don't and you tell me a dog is just a dog, I'm still confused, right? So I can use property 1 or I can use property 3 or anything else. So I'm going to start on the left-hand side. All right, so here's what I'm going to do first. I'm just going to use the rule of exponents. I'm going to bring the y factor from the denominator to the top. I know I can do that as long as I do what to its exponent? Change its sign, right? Since it's y to the positive first in the denominator, it's now y to the negative first in the top. Now the reason would just be rules of exponents, right? I haven't used any log rules. I just brought the factor to the top. But now I've turned it into a product. And so now I can use property 1, yes? Property 1 says that products turn into what? Multiplication becomes addition, right? So that's going to be the natural log of x plus the natural log of y to the negative first. And the reason would be property 1. We don't have to write the reasons as long as we show the steps. And now I can use property 3. What can I do with that negative 1? Bring it out front, and it becomes the natural log of x. When I bring it in front of that term only, it becomes minus natural log of y. Does that look like the right-hand side now? Yeah. So when you're done, you can be real fancy, and you can write what mathematicians typically write at the end of their proofs, which is QED. Does anyone know what that stands for? Or has anyone ever seen that before? QED. Okay, good. At least you've seen it. It's typically in a proof. It's an acronym for a Latin phrase. Quid. This is a common crossword clue. Erat, quid, yeah, like Quidditch. Quid erat, and this is a great word here. Demon, not demon, but demonstratum. Ooh. Yeah, demonstration is the root word there. Yeah, so this translates to roughly that which has been, erat is which has been demonstrated. That which has been demonstrated, which is just a fancy way to say, I did it, right? Dora says, lo hicimos, right? Right? We went from property 2 and we brought the factor to the top. Yeah, we did it. We did it. We did it. Yeah, right? That was Dora. We just didn't have to look out for a swiper here, right? Y'all grew up with Dora. I know you did. Or his cousin, Diego. His cousin? Her cousin. Oof. She did have that short haircut. Yeah, okay. All right, let's do the next one. It says prove property 3. So just to finish off this one, property 3 is the one that says the natural log of a to the nth power is n times the natural log of a. So I'll start on the left-hand side. This will be the last one we do for the day. A to the n, that's the same as the natural log of a times a times a dot 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 times a, right? And how many of those factors of a do I have? I should have n of them, right? And again, the rule there would just be rules of exponents. That's what an exponent does. It tells you how many factors you have of that type multiplied together. Well, now I can use property 1. That's the natural log of a plus the natural log of a plus dot 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 plus the natural log of a. And how many of those terms do I now have? I have n of them. And now if I have n of the exact same thing that I'm adding together, I can multiply it. So that's how many of them? N of those. And that's what the right side is. So we could say, lo hacimos. Okay? We did it. We proved it. Okay, so we got a lot done for today, seeing as we haven't done math in 9 days. That was a good break into the next section. Remember, there's a worksheet out here. Practice, 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 and enjoy the rest of your day. Adios.